Okay, guys, sorry I'm not there today. I'm going to give you some answers for the homework. If you did it without the calculator, great. If you used it, like I said, I will live. Okay, so basically you're doing an input into a function and finding the answer. So when 3 goes into Q1, we get 3 squared, which is 9. For Q2, we get 0 squared, which is 0. For Q3, we get negative 3 squared, which is 9. If you put it in your calculator as negative 3, oop, why is it not drawing? Negative, oh, that's why it's a picture there. Sorry, hold on. If you put this in your calculator as negative 3 squared and hit enter, you'll get back negative 9. It's because these parentheses need to be around that negative number. Anything squared is going to be a positive answer. Q4, 2 to the x, that's 2 to the third, which is 2 times 2 times 2, which is 8. Q5 is 2 to the 0. Anything to the 0th power is 1. Anything to the 0th power is 1. Okay, on to Q6. That is, Q6 is equal to 2 to the negative third. And you're probably not sure of how to deal with that negative power. But whenever we have negative signs, we can always change our function. We can move it to the bottom of the fraction, becomes 1 over 2 to the third. And that becomes equal to 1/8. Negative exponents don't make negative numbers, they make smaller numbers. And that's why that one comes out to be 1 over 8. Okay, Q7 is x to the 1/2. So that's 25 to the 1/2 power. 1/2 means radical. And the square root of 25 is 5. Because 5 times 5 is 25. Q8 is going to be 0 to the 1/2 power. That means what times what gives us 0? And the answer to that is 0. Q9 is x to the 1/2 power. Find h of negative 9. So that means this is the same as the square root of negative 9. Well, there is no real answer to that. You could write NRS, no real answer. If you think back to Algebra 2, the answer is actually 3i. We'll talk about that more in later times coming up. And Q10 says what axiom for real numbers is illustrated by that function right there. And there's a bunch of words on there, and the first thing is to eliminate possible choices. The thing that's changed is the stuff on the inside. I don't know why I can't write on that right now. But there's x plus 5 on one, and then there's 5 plus x on the other. That has to do with addition, so the choices are either C or D. And you'll notice that the things have moved. The 5 and the x have moved. When you move, it's like commuting. So the correct answer is choice D, the commutative property. Okay, in class today, you're going to work on the following. That's any pictures of your work. The first thing you're going to do is you're going to complete problem 10 in the exploration we were working on yesterday. Now remember, this is a quadratic. It has a turning point. So Nico, don't worry, we're just using those two matrices. Okay, and I'm going to give you a couple of hints. The answers go in 1, so I'm just going to fill it in for this point right here. So on the top, I'm going to put 26.6. And if you look back in your notes, you'll see the x value goes here, the square of it goes here, and 1 goes here. And you can fill in the rest. Now the reason for that is for the quadratic, you don't need to worry about filling this out. The equation is ax squared plus bx plus c equals the answer. So the answer we have is 26.6. Okay, and my x value is 3, so I'd fill that in. X squared is 9a plus b times 3, which is 3b, plus 1c. And that's where those numbers come from in that matrix. You'll fill that in, put it to the negative first power, and your calculator will give you back your A, B, and C. You have to take a picture of that and send that over to me. If you don't have your phone or device, just make sure your name's on the page and have someone else send it for you. And the other problems you're going to work on, I'll give you some hints on them. Oop, wrong way. Let's go backwards. Or let's make a new page. Okay, I just realized I wasn't recording for a little while. And I'm hoping I didn't skip any problems. I don't think I did. Really quick, I'll go back to 6, and I'll just say for 6, there's a funny joke that I've been using in class. Well, your definition of funny may be different than mine, to say why, and I'll give you the first line of it, which is, what did the quadratic function with a greater than 0 say the quadratic function whose a was equal to 0. And then 7, I'm not really going to go into description on. I'd like to see what answers you come up with, and we'll discuss that in class tomorrow. Once again, I'm sorry I'm not there today. We're going to give these problems a shot, and we'll discuss them tomorrow. Please send me a picture of all of your work before the end of class, and I'll see you tomorrow. Take care.